Okay, so today we'll be doing multiplication and it's quite similar to addition itself. So yeah, let's begin. Let's create a folder file inside the 8086 directory. So let's call it mul.asm. Okay, so first thing first, we have to write the data segment in the code segment. The code segment. It's quite similar to the addition. We have to take the inputs first, four inputs and all. So code ends. Then we have to start it first assembly directives as you would see. Data. Then start. First move data into AX. Then move AX into DS. Okay. For stopping, we have to move 4C00H into AX register. So, yeah, 00H and call the DOS interrupt, which is DOS21H. Okay, now we have to specify this end. So end start. Okay, now let's write the procedure for printing. Print entity, and then we have to return also. So return for that. First we'll call the function. Let's assuming content in AL register. So first we'll move it into DL. Then we call the function which is move AH, 02H. And call the DOS interrupt. Okay, so this is for printing, and now for input. Input NP return. Okay, now for each character we'll make a function, make a code. It is basically calling the function. So to call the function, we have to move 012 into AL register and call the DOS interrupt, and this will be stored inside AL. So we are using BL, BH, CL, CH. So we can store it in BL. Similarly for all other four characters. Okay, so we got BL, then BH, then CL, and CH. Now we have to subtract 48 from each because it's in ASCII currently. We have to convert it into decimal. So sub BL comma 48 sub BH comma 48 sub CL comma 48 CH comma 48. Okay, so we have subtracted. Now we have to basically add two digits to make it one digit. For example, if it's 21, we have to multiply 2 by 10 and add 1. So here we'll multiply BL into 10 plus BH. So BL into 10 plus BH. Similar with CL. So for that, first I will move 10 into AL. Now we'll say mul BL. The result will be stored in AL, so I have to move it into BL again. Then I will just add BH into BL. Okay, similarly for CH, I will do. Sorry, this is not BL, BH. Okay. So CL, CH. Okay, so now we got the numbers in BL and CL. Now we can write it here. Input is the main program. So first we'll call input. After calling input, now we have numbers inside BL and CL. So as we're doing multiplication, first these are two 8-bit numbers. So we need the answer to be a 16-bit number. First, what we'll do is move one of them, let's say BL into AL, and say mul CL. So the answer will be stored inside AL, AX. The whole answer, the 16-bit number, will be stored in AX. Okay. Now we'll just move the AX into BX register. Okay, AX into BX. So now we have answer in BX register. Now we have to display it. For displaying it, let's make a function. So display proc display np. We'll return it. Okay. First thing first you have to compare if it's the 16-bit number is less than 9. So for that, let's make C raised with 9. The CX has 9 now. So now I'll compare the CX with my BX register, which has a number. Now if BX is greater than CX, then I'll move to more than 1. So jump to, let's say, 2. That's a label. That's basically denoting it's more than 9. So if it's less than 9, then we can use this label 1. No need to write label 1, but still it's for convenience. So if the number is less than 9, it's in BX, so we'll just print BX. For that, I will just move it into AX register, because for printing I need it to be in AL. So now I just add 48, so I can get it converted to ASCII. After converting it to ASCII, I will just call the print function. Okay, so after this I have to return to the end of the display function. So I will use jump end. Okay, so let the end be here. Okay, now let's write the to label. Okay, now here first of all we have to multiply, divide the BX register by 10, and then we get the quotient and the remainder. Remainder we have to display, but before displaying the remainder, we have to take the quotient, again check if it's less than 9. If yes, just print it, or if it's not, again divide by 10. So we need a recursion there. So let's divide first. So move CX 10 into CX. Let's move the register into AX, or BX register into AX. So for dividing, I will just write divide CX. What it basically do is it divide BX by 10. So the answer is stored in AX. Now the thing to note is the answer stored, the AX has the higher nibble has the quotient, the lower has the remainder. So basically I have to perform the recursion again on the higher nibble and just display the lower nibble. So first I'll move BX comma. So for doing recursion, I have to move the lower nibble, a higher nibble, into BX. So H, and I will store the lower nibble, which is C, which is AL, into register CH. Now one thing to note here is AH is 8-bit register, BX is 16-bit register. So there might be some problem. So what we can do is we can say after I assign the AL value into CH, I can subtract, basically clear the AL register, and then I can just pass the AX value itself. Okay, so I can do this. Yeah. Okay. So now I have to call the recursion. So I'll just call display again. But one thing we have to notice, the C register might be used again, as we are using CX9 here. So we need to push it into stack before calling another recursion. So let's push it and pop it so we won't lose the value. Then we'll just print the remainder, which is can say move. You can move CH into AL. Then as usual just add 48 into AL, convert it into ASCII and call print. Okay, so this is the code. Now I will just call the function. Okay, call display, the main function. Okay, now let's test it. Mount C. So the folder name is mul. Okay, I have a lot of errors. Data emitted line. Let me check. I think there is error with writing the segments. So data segment, data ends, code segment spelling is incorrect, that's why. Okay, so we'll just do it again. Okay, no errors. Link mul and just run the mul. So let's say 1 into 1, it's okay, it's working. 2 into 2, it's okay. Now let's go 2 digits. So 4 into 4, oh, it's not showing, so it means the code has some problem. It is getting stuck somewhere. So let's just check if the interrupts are given fine. Yeah, okay, interrupts are fine. I think the problem is with, I think the quotient is in AH rather than AL, so I have to clear AH not AL and pass yeah, this little tweak I have made here. Okay, so the problem I figured out is I can't divide using 16-bit, so I have to divide using a 8-bit number. So I'll just changing it here. Instead of moving 10 into CX, I move it into CL and divide using CL. Okay, now let's test it. Now let's see. Decimal virus. Okay, now as you can see, it's showing like okay output for 2 digits. Now let's go 3 digit. So one 3 digit number can be 30 into 50. Yeah, so it's working now. So this is how you do the multiplication. So the things to remember is wherever I encountered is for division, I can only divide using 8-bit number, and yeah, that's error encountered. Nothing you have to see is that while you give the quotient for recursion, you have to clear the AH register. So basically the higher nibbles are cleared and the lower nibbles are given again to be processed by the same function. The remainder is printed here. So after all this like recursion is completed, only this remainder will be printed. So if it's like 180, first 0 is the remainder. So 18 goes again to the recursion function, then 8 is the remainder, then this again goes to recursion function, then it enters this one, like it only has 1, so then it displays 180. Yeah, okay then, see you in the next video.